In this video, we're going to focus on some probability problems and we'll try to solve them using probability trees. In my first question, Ash flips a coin and Peter rolls a dice. We need to work out the probability the result is tails and a 6. So first, we're going to look at the possible outcomes when we flip a coin. So we can either get heads or tails. The probability of getting heads is a half and the probability of getting tails is a half because it's one out of two possible outcomes. Then we look at rolling dice, and we want to focus on two types of outcomes. One of them is getting a 6, and then the other one is getting the numbers from 1 to 5, because our question focuses on getting a 6. Okay, so the probability of getting a 6 is 1 over 6, and probability of getting numbers 1 to 5 is 5 over 6, because there are 5 numbers, 1, 2, 3, 4, and 5, out of the 6 numbers that we have on the dice. Okay, and then when we get tails on a coin, and then we have the same set of possible results for a dice. So these are the probabilities on our tree. Now we need to look at all the possible results, combined results for the coin and the dice. So first, we can get heads and a 6. We can also get heads and the number from 1 to 5. We can get tails and a 6. And then we can get tails and the numbers from 1 to 5. So now to find the probability of getting heads and a 6, we need to go along these two branches. Okay, so I need to now times the two probabilities. So to find the probability of getting heads and a 6, I need to times a half and a 6. Okay, so that gives me 1 over 12. To find the probability of getting heads and the number from 1 to 5, I need to go along these two branches. So I need to times a half and 5 over 6. And then we get 5 over 12. And then the same way, to work out the probability of getting tails and a 6, I need to times a half and a sixth, and that gives me 1 over 12. And to find the probability of getting tails and a number from 1 to 5, I need to times a half and 5 over 6, which gives me 5 over 12. Now remember that our question is asking us about the probability of getting tails and 6. So we are interested in this particular result. So the final answer will be 1 over 12. In this question here, we have some box with marbles. Okay, there are black and white marbles, and one is picked and replaced. And this is a very important bit of information in this question, that the marble is replaced. And then another one is picked. And what is the probability that both picks are the same color? So we need to draw the branches. We have the first set of branches, which is for the first pick. Then we have more branches for the second pick and some space for the results. So first we need to work out the probability of getting black and white. You can see that you have 3 marbles that are black, and there are 7 marbles altogether. So the probability of getting a black one will be 3 over 7. So now the probability of getting a white one will be 4 over 7. Now for the second pick, okay, again I want black first, so that is still 3 over 7. And that is because we replace the marble. So the number of marbles, okay, does not change. The probability of getting a white one is still 4 over 7, and we have the same probabilities on the other set of branches. So now I need to analyze the different results. So the first, okay, if I go along the top branches, I'm going to get black and black. Okay, so that means that is 3 over 7 times 3 over 7, which is 9 over 49. Then we can get black first and then white. So that's black and then white. So that's 3 over 7 times 4 over 7, and that is 12 over 49. Then we can get white first and then black. Okay, and that will be 4 over 7 times 3 over 7, which is 12 over 49. And then in the last one, we have white and white. Okay, so that's 4 over 7 times 4 over 7, which is 16 over 49. Now, the question is that we want the probability of both pigs to be the same color. So either black and black or white and white. So for the final answer, we need to add the two probabilities. So the probability of getting black and black is 9 over 49. And then the probability of getting white and white is 16 over 49. So then the final answer will be 25 over 49. So this is the answer. This is the probability that both pigs will be the same color. Now, in this question, the probability of Jill passes her geography test is 0.7. The probability that Jill passes her science test is 0.6. What is the probability she passes only one of the tests? Okay, and this is just to show you that probability also can be expressed as decimals and not only fractions. So the first result is for the geography test. So you see that the probability that Jill passes her geography test is 0.7. So if the probability that she passes the test is 0.7, the probability that she fails must be 0.3, because remember that two results need to add up to 1. Okay, now the second set of branches is for the science test. Again, now for the science, the probability that she passes her test is 0.6. So the probability that she fails is 0.4. And again, it will be the same for this set of branches. Now we want to analyze the different results. Now, what is the probability that she passes only one of these tests? So if I go along the top branches, that means that she passes and passes, then passes and fails, then fails and passes, and then fails and fails. So we want the probability of her passing only one of these tests. So for example, that will be this result when she passes and fails, or when she fails and then passes. So I'm going to skip the other two probabilities, and I'm only going to work out the ones that I'm interested in. So to work out the probability of her passing then failing, I need to times 0.7 by 0.4, and that is 0.28. Now the probability that she fails and then passes is 0.3 times 0.6, which is 0.18. Now to get the final answer, we need to add the two results. Okay, so that is 0.28, add 0.18, and that is 0.46. And here we have another question involving marbles. However, this question is different from the previous one because a marble is not replaced. Okay, so we want to work out the probability that one or more black marbles are picked, and we also want to work out the probability two marbles of the same color are picked. So let's have a look at our tree, and we need to work out the probability of getting a black one first, and that is going to be 3 over 9 because we have 3 black marbles and 9 altogether, and then the probability of getting a white one will be 6 over 9 because we have 6 white marbles and 9 altogether. When we move on to the second pick, okay, things get a little bit more complicated. If the first pick was a black marble, then now I don't have 3 anymore. I have only 2 left, and the total is not 9, it's 8, because one marble was already taken out and not replaced. Okay, now if I want to work out the probability of getting a white marble, that is going to be 6/8, because the number of the white marble hasn't changed, but the total has. Okay, so that's 6/8. Now, if the first marble was white, then the probability of getting a black one is 3/8, because there are still 3 black marbles and 8 altogether, and probability of getting a white one is 5/8, and that is because now I have only 5 white marbles left and there are 8 in total. Now for the final results, okay, I've got black and black, so that is 3/9 times 2/8, which is 6/72. To find the probability of getting a black one and then a white one, that is 3/9 times 6/8, which is 18/72. To find the probability of getting a white one and then a black one, that is 6/9 times 3/8, which is again 18/72. And then the probability of getting a white one and then a white one again, that's 6/9 times 5/8, which is 30/72. Now, the first question was about probability one or more black marbles are picked. One or more. Okay, so here I've got one or more, here and here. So to answer this question, I could add all those probabilities. Okay, so that is 6/72, 18/72, and then again 18/72. And that is 42/72. Okay, so the answer to the first question is 42/72. Now the second part of the question, what is the probability 2 marbles of the same color are picked? The same color, that means here, black and black, or here, white and white. So to answer this part of the question, I need to add these 2 fractions together, and the answer will be 36/72. Okay, and the answer to this question was 42/72. In this question now, we have 2 football teams, okay, and their matches. So Woodley United will play 2 matches against Anfield Wanderers, and the probability they win the first match is 2/5, and then if they win the first match, the probability of winning the second match is 4/5, and if they lose the first match, the probability of winning the second match is 2/5. So here we have again conditional probability, because the second result depends on the first one. So we've got the first set of branches, so the probability they win is 2/5, so the probability they lose will be 3/5. Now we have the second set of branches. Okay, now because if they win the first one, okay, the probability that they win the second one will be 4/5, so the probability that they lose will be 1/5. Now if they lose, okay, the first match, then the probability of winning the second one is 2/5, so the probability that they lose the second one will be 3/5. Now the final question is, what is the probability they win both matches? So here I've got win and win. Here I've got win and lose, lose and win, and then lose and lose. I want the probability they win both matches, so that's this one here. So to find out the probability of them winning both, I need to times 2/5 by 4/5, okay, and that is 8/25, and that's the answer to my question.